Greetings, everyone. Peter Dyke here, Executive Director of the Alliance for PE Pipe. Welcome to another edition of the PolyPodcast. And I must say, I apologize for the last couple of months. We've taken a break here as we have produced Showcase and done a few other things. So I guess welcome back to you as well, and thank you for your patience. Joining me today is my colleague, Dan Landy. Greetings, Dan.
Hey, Peter. I'm excited for this one. Hopefully answer a lot of the questions that we're getting coming in regarding cold weather over the past few weeks as things cool down across the country.
Well, Dan, you called it. You know, we held a webinar recently, and we had, what is it, 380 people on for cold weather. I didn't think we could get that many, but we had, honestly, 600, just shy of 600 reservations, and 380 of them showed up. That's quite a turnout for a webinar, wouldn't you say?
Yeah, and we did expand it a little bit at the end to be inclement weather. And I think some of the warm weather people were curious and seeing how that comes over to the hot temperatures as well.
Yeah, cold weather sounds better than, inclement weather podcast, Also, Dan, I wanted to mention that we thank our good friends Richard Colassa, Dustin Langston, and Josh Cottle over at WL Plastics for sponsoring another webinar.
Yeah, we asked a lot of questions during that webinar about the differences between fusing polyethylene and steel, and Richard was handling those. I didn't, that does make sense comparing the two, but yeah, as always, really support the programs we have. We're very thankful.
Yeah, so we'll hear from them a little bit later in the program. So Dan, let's introduce our panelists today. So instead of a presentation in this podcast, Dan, we're just going to have a conversation. So please interject when you'd like. Joining me first is Chris Waite from Secor. Chris is up in Gillette, Wyoming. Welcome, Chris Waite.
Thank you, Peter. I appreciate the opportunity to present on this.
Yeah, well, we're glad you're here. You're a member of our Certified Professional program. You're also an expert in all things polyethylene. Gosh, I'm amazed at all the things you do, running your branch up there, running the fab shop, getting out on job sites and selling pipe. You're a busy guy.
Yes, sir. I spend a lot of time on the road. I spend a lot of time in the office. The days don't get any shorter, that's for sure.
Yeah. Have you had trouble getting help up there in Gillette?
I've been pretty fortunate. I've got a pretty good team up here of 5 solid people, and they've been with me for quite a while, and we're just gangbusters on everything.
So how long have you been in the poly world, Chris?
I started in the polyethylene world in sales in 2011. Prior to that, I was in the field fusing pipe.
Awesome. So you come at it honestly. Your boots are dirty.
Yes, sir. Started at fusing, then moved into mechanicing, and been down to McElroy and seen Mr. Johnston and got my certification working on McElroy equipment, and then moved into sales and management, and that's where I'm at now.
Good. Well, I look forward to learning from you in this broadcast. Our second guest is Dave Mosier with Core & Main, coming to us from Central Illinois. Welcome, Dave Mosier.
Thank you, Pete. Pleasure to be here.
So how long have you been in the business?
It's been 10 years now that I've been doing high-density solid wall polyethylene. I came over from the drainage side of polyethylene before with the corrugated plastics, but I enjoy working under pressure more than I did under gravity. So
does that mean it's a lot of pressure working at Core & Main?
No, just a lot of pressure in the pipe.
Oh, got it. Oh, yeah. Oh, you're in pressure pipe. Oh, got it. So tell us, what do you do for Core & Main, Dave?
So I'm a regional sales manager. I oversee our fleet in the North region, which is about 10 states. We go across the northern tier, which includes the Dakotas, Colorado, Minnesota, Iowa, Wisconsin, Michigan. A lot of cold states are included in my territory. So we got a nice fleet of equipment and 10 technicians that are out there fusing pipe as well.
Well, you would be a great resource then for me to keep sending us images to post in social media in cold weather applications. I'm sure you've got quite a bit of experience there.
Yes. Yeah. I'm constantly harping on my guys when they're out in the field to get some pictures, because there's lots of interesting things. And to them, it might just be another Tuesday, but to somebody else, it's might be something they haven't seen before and they can learn from.
Yeah. Well, you send them and I'll get them out there. So welcome to the podcast, Dave.
Thank you.
Great to have you here. And also I want to say thanks for supporting Showcase so much and sending so many of your people to Showcase in Phoenix. Also,
That's
my
been
third,
real worthwhile.
have you found it to be worthwhile for your team?
Yeah, it's a great refresher for people who've been in it for a while, but it's really been great when I can send some new people in there. Some of my inside sales reps, some of my outside sales reps that haven't sold a lot of poly. They really get to meet a lot of people in the industry. Put those faces with the names and start to build those relationships that's what we build our success on.
Yeah, that's for sure. So if they have any tips, Dan and I and my team are going to start working on the program for this year, next month. If you have any tips on new content for next year, let us know, please. And my final guest today is Jim Johnston. Jim is Chief Technology Officer. Did I get that right, Jim Johnston?
That's right. That's right.
So CTO at McElroy down in Tulsa. And for those of you that don't know, McElroy's been a big supporter of the Alliance for PE Pipe. And for that, Jim, we are very grateful. Welcome to the podcast.
Thank you. Thank you. And I am most appreciative to be a part of such a great group of guys and the experience that's here. So really appreciate you having me as part of this. And both Chris and Dave bring a lot of field experience and a lot of overall experience to really help us with this discussion. So.
Well, who knew, Jim? I mean, I'm sure you knew how important cold weather operations are to the success of your machines, but I didn't really think we'd have that big following at our webinar. So Dan said, Peter, why don't you just make it a podcast too? So here we are. Before we get started, Jim, tell us a little bit about what you do at McElroy Manufacturing.
So I touch a little bit of a lot of things. I'm in charge of standards development throughout the globe. So any 3 or 4 or 5 letter acronymed organization, we do a lot of work with them, as well as industry relations with the pipe companies, helping pipe companies develop pipe fusion standards for new products, a lot of the other corporation things. Also under my group is business intelligence and IT, a little bit of new business development, and just a lot of other touch within the organization.
Yeah, it sounds like you're in a lot of things, and I'm sure if you have an executive committee, you're there. You've got your finger on all kinds of things. So, thank you for sharing some of your time with us to educate our listeners on this important issue. So, guys, we got to this because for a variety of reasons. First of all, the Alliance gets a ton of questions about cold weather operations. You know what? All of us aren't necessarily expert in it. So my guys came to me and said, hey, we ought to do a webinar on this. But actually, Dan, it started before then because we decided to do a session at Showcase on it. Isn't that right?
Yeah, I reached out to Jim and I was very, very relieved that he had already put a deck together for it. I guess, Jim, you've given that presentation at some point in the past?
This is not a new topic. So we've had this discussion quite a bit. And so it was perfect timing to hit a larger and larger and larger audience, especially with the Alliance and now with the podcast, because cold weather fusion happens year round. It's not just a North American thing. When we're sitting here basking in the middle of the summer, we have some folks in the southern hemisphere that are dealing with cold weather as well. So it's pretty much a year-round opportunity to have some conversation around this. So it's been a really good piece.
So for the sake of our listeners, PPI put out in, I believe it was 2022, Jim, and I know you were on the committee, basically a one-pager on cold weather operations. And I was delighted to see it. And I will say it was kind of a modest document. Usually PPI publishes documents that are multiple pages, 20 and 30 pages. This was one page, but really good content, and really helpful to a lot of people. But I will say it didn't go into much depth. I mean, I might say, hey, get a heater, but didn't really talk much about blankets or that kind of stuff. So in our deck, and with your help, Jim, we tried to talk about some of the unspoken things that were not included in that. Tell us a little bit about PPI's process and a little bit about that document.
So that particular document came out of the MAB, the Municipal Advisory Board, and a lot of requests from the municipalities who are accepting polyethylene more and more and more, and especially as we see more of this use in northern climates here in North America, the questions come up of what do we do? Is there something different that we do? Do we need to do a whole lot different? And the simple answer is that there's not a thing you do to change the procedure. And you're going to hear us talk about this quite a bit, is change the environment, don't change the procedure. And that was really kind of the primary message, is don't develop a new procedure. The procedure that's out there is tried and true. It works. Make sure that your environment is good for producing for managing that procedure. And that was really the focus of that effort. Several years ago, the underground heat source industry actually was one of those that first started looking at this, and that was an article I wrote. I think it goes back to 2017, and around what do we do differently. The question always comes up of what do I change? Do I turn up the heater? Do I do something different? Do I change the pressures? Do I change the times? And the simple answer is no. Make sure that you protect the environment and make sure that you're able to do some things and be careful when you go through the steps.
So in that document from the MAB, so the MAB is the Municipal Advisory Board of Plastics Pipe Institute, and that's that group that provides a lot of great background and knowledge and thinking. Camille Rubiez does a fantastic job with that group. And thank goodness that we have their guidance and their commitment to the industry. But they basically bring up F2620 from ASTM in their gym. Does that cover cold weather operations as well?
It gives some direction there in F2620 around the temperature at which you can fuse down to this temperature, and after that, you want to make sure that you put your system into a controlled environment so that you can heat up the environment and continue to follow the procedure. Again, don't change the procedure, change the environment. So make sure that when you're in that environment, do those things and prevent wind and cold and water from getting into your process. And that was a little bit of the impetus of the discussion that we went through of doing inclement weather rather than just cold weather. And it applies in dusty areas, rainy weathers. Let's say it's 70 degrees, but it's raining. You don't want to be outside without a cover over your system. You can still fuse, but you dry the parts, you do everything else.
So I was in Houston or Austin last week, and I met a guy from ISCO, and he travels all over the world doing fusion. And I brought up the success of the cold weather webinar, Jim, and he told me he travels with a tent all over the world, and even on nice days, he's using a tent. Why would he do that?
There's a number of reasons. If you and I are out there fusing pipe, it's better for us to be under the tent. One of the most important pieces of machinery on that job site is us. Because if we're not working, the machine's not going to work. So
yeah, great point.
Protect your operator. Keep your operator in good shape, then the machine can be in good shape. But you've got the effect, solar radiation. So if I'm fusing black pipe, then I'm gonna heat up those zones of that black pipe that are exposed to the sun. So if I can mitigate some of that, if I can if I can keep wind from blowing dirt into my tent, keep contamination out of my fusion zone, if I cap the ends of the pipe, if I just do a lot of things that help that operator be better at his or her job while it's out there. It's just good practice. And then when it's time to do something and it's raining or it's cold or something else, the tent isn't new to me. I'm not
Right.
changing what I've done. I'm still doing what I've always done. I always fuse in a tent.
All right, it's time for a technical minute here with our good friend Dusty Langston and our sponsor WL Plastics. Hello, Dusty.
Hey, Peter, how you doing today?
I'm great. Thank you for sponsoring yet another Poly podcast.
Yeah, absolutely. These are one of my favorite things out there as far as media for HDPE pipe. So I love podcasts, listen to them all the time. Love this one.
Yeah, well, thanks for what you do and what you do for WL. Dusty, this is a great conversation today about cold weather applications. You know, we've kind of riffed on this idea of cold weather and polyethylene and how it performs so well. Give us your take on polyethylene pipe in cold weather applications. What's one of the most common questions you get as a technical expert with pipe?
Yeah, definitely the most common one is going to be, hey, it's very cold outside. Do we need to worry about breaking this pipe? You know, as it gets colder, is this an issue? And the HDPE pipe is still a very ductile material, even at very cold temperatures. Very, very common. Edmonton, Calgary, Alberta, negative 40 degrees. And you can still have that pipe installed above ground outside, and it can handle those very, very cold temperatures. The glass transition temperature, for example, of HDPE pipe is negative 130 degrees Fahrenheit. So it's still going to act in a ductile manner. It will be stiffer, but it will still be a ductile product. Along with that stiffness, another question I get a lot is, hey, if we do have colder temperatures and the pipe gets stiffer, it technically gets stronger. Can I increase the pressure on this pipe? And while we don't recommend it all the time, you absolutely can. As the pipe gets colder, it does get stronger. One thing to always take in consideration with that is because it gets stronger and stiffer, your water hammer effects are going to be a little bit higher. So if you do take in consideration that, hey, I'm going to run this at a higher pressure because it's always going to be cold, just keep that in mind that you need to make sure you're doing your pressure surge calculations correctly with that cold temperature. But it's very, very common that we see that, especially in like chiller processes and things like that, chilled water, where they're running at a much colder temperature, they will take advantage of those higher pressure classes.
Yeah, one of the things we learned, Dan and I did about Fairbanks in one of our presentations, Dusty, is that they're big fans of polyethylene, even above grade. What are some of the above grade issues we have to deal with polyethylene in cold temperatures?
Definitely a safety thing. Just because the pipe is still ductile, you definitely still don't want to hit it. So making sure that it is in a safe pathway when it's above ground. One other thing is to take into consideration expansion contraction. If we have it above ground and you're going to be seeing temperature swings, even if it's conveying the same temperature, cold water, glycol, something like that throughout the year, you still want to know what the outside temperature is doing and the thermal effects that can happen from that. So you want to make sure that you are taking that in consideration and making your pipe supports or your pipe restraints built adequately for those temperature changes. Correct. Yeah, they're just protecting things. So we have a lot of companies that do the insulation wrap. The insulation wrap doesn't hurt the pipe at all. A lot of people worry that it's like a chemical reaction, is that because it's a cellular foam ultimately with a jacket. And so they worry that that's going to chemically hurt the pipe. It doesn't affect the pipe at all, even as it cures in those higher temperatures from curing. Again, it's not going to hurt the pipe at all. And then with heat tracing is awesome and very commonly used. The big takeaway there is it needs to stay under 120 degrees Fahrenheit for the heat trace temperature. That's in our field notes, our technical document for field procedures. Make sure that your heat trace is under 120 degrees.
So when those companies heat the pipe either with heat tracing or they put insulation around it, do they hurt the pipe at all, Dusty, or are they just protecting the fluid that's flowing through it?
No, there will be a jacket around the wire. It's also very important to have some kind of a safety control so that if you have a runaway, if you have a runaway system that kind of arcs through, it can pull a ton of power. That's how you know how to safely shut it down. Is if it starts pulling more power than usual, it should have an automatic off switch. Because if that does start just pulling power as much as it wants, it can melt through its jacket and then melt into the pipe.
Got it. Hey, Dusty Langston, always great to talk to you, and we thank you and WL for your support of the Poly Podcast. We look forward to the next one. And now, Dan, let's get back to it.
Thanks, guys.
So, Chris, one of the items, item number one, actually, in the MAB document says remove snow, ice, and melted ice from the stored pipe. So, Chris, when my pipe is in the fusion machine, how far back do I have to remove the snow so I don't gung up the works? Get that facer all wet and dirty, and obviously, but also the heater. I mean, imagine getting all that stuff on the heater. How far back do you have to go, Chris?
You have to go at least as far as the jaws are going to clamp on that pipe. I recommend to everybody you go at least like 3 to 4 feet, depending on the size of the pipe, obviously. And that's not just outside, that's inside also. Because if you get that water running down against that heater while you're doing your heat soak, it's going to boil immediately, and it's going to put moisture bubbles in your fuse, and you're going to have a bad fuse in the end.
Right. Okay. So you go 3 to 4 feet, and that's while it's snow or ice. And then how much time do you have to give it to dry?
Well, until it's dry. I mean, ultimately, you can wipe it down. You need to make sure that that whole thing is dry, both inside and out. If you don't, if you get any moisture rolling up against that heater, it's going to create a bad fuse in the end.
Right. All right. Well, let's riff on that for a second. So, Jim, if I do a fusion and there was water on the heater, does that mean there could be water on the face of my pipe?
If there's water, so what it can do is it can bubble up and leave a void in theory. So we're talking about a 400 to 450 degree heater, so that water's not going to stay long. But you want to avoid that moisture so that you don't get any bubbling, don't get any voiding that occurs there, and it'll go pretty quick. If you can also use the heater by bringing those pipe ends close to the heater without actually bringing them in contact, and use that heater to help dry off some of the pipe as well. A lot of operators will also clean with isopropyl alcohol. That will help get that water off quickly as well. So once you wipe it down, get off the bulk of the dirt and the water, wipe down with isopropyl, that will evaporate quickly and can get that off there. But we want to avoid any potential contamination of any kind. So I'm less concerned about the water being there, as if the water's dirty, that you've got dirt that gets on the heater or the end of the pipe.
So if I'm trying to cut corners and I let the water bubble away, it could still leave dirt that was in the drops of water, and that could contaminate my pipe end.
Correct.
Yeah.
And that's why you want to wipe down that heater and keep it clean. And
so Dan and I had a disagreement, Jim, in Texas, because he said, go ahead and wipe it with isopropyl alcohol. And he was standing in front of a group of people teaching them about how to do fusion. And I interrupted him. I said, no, 2620 doesn't cover that. So then I went and looked at 2620-20, and it absolutely did. Was there a change in that from 17 to 20 that I missed?
The truth shall set you free.
yes. Yep, Dan's right. I will have to go back and look and see when that was. In general terms, when you face the pipe, that is as clean as it's ever going to be. But cleaning the pipe prior to facing, isopropyl has or toluene has been in there for a long time.
Okay.
I'm not toluene, sorry, acetone.
And Jim, the
acetone.
isopropyl is just meant because the higher alcohol, the less water-free evaporation. Is that correct?
Correct. So there is a minimum content. There's 91% isopropyl alcohol. So one, you want it to evaporate quickly and be a little bit of a surfactant to get dirt and other things off. But it's more about evaporating quickly so that you don't have any surface content there.
Okay. Great.
So even if it's alcohol,
Correct
you
me
don't
if I'm
want to
wrong.
see wet.
But go ahead,
Correct me
Chris.
if I'm wrong, Jim, did they not change that standard in 2013 in that revision? It used to say if you used isopropyl alcohol, you had to go back and clean it with water afterwards. Am I
Right.
incorrect in stating that?
That is, yeah, and that was a mistake in the document that was corrected in I believe 17 or 19, because why would you wash the pipe and then wipe it down with alcohol and then wash it down again with water? So that was an oversight in the document where it said that wash with water after wiping down with alcohol, and that was taken out either in the 17 or 19 revision.
Yeah,
Okay,
that was
so
an
is it-
argument that I've ran into a lot.
What's that?
Just once you've cleaned it with alcohol, why would I have to go back and clean it with water again? I've had a lot of people argue that, gas distribution companies, water, municipal water and sewer companies, because all these guys were cleaning it with alcohol, then cleaning it with water again after they cleaned it with alcohol, and nobody could understand that aspect of the standard.
Okay, so
I
we're not
started
doing that
actually
anymore.
teaching it.
No, we're not doing that anymore.
Got it.
All the more reason to use the current version of the standard,
Yeah, and right now we're
whatever the
on
current version may be.
20 ASTM 262020.
Correct.
Okay, so that's the 2020 version of ASTM F2620. Okay, I want to get a couple more basics out here. And let's talk about if it's really cold, fellas, and you don't have a tent. So I'm assuming, Jim, if you have a tent, that you have a heater in the tent, so you're keeping it at 40 degrees or 50 degrees, something like that, and you've got sides. So is that a best practice, Jim? Okay. Jim
Yeah,
can't hear
absolutely.
you.
The
Okay.
being in a container, a tent, an enclosure is best practice.
Okay. So it's not just a roof; it's a roof with sides.
Ideally, I mean, best case, minimum best case is a roof. That gives you that overhead containment. Again, back to the operator. How comfortable is your operator? If it's -4 degrees Fahrenheit outside, how comfortable am I as the operator standing out in the cold? Give everybody some capability.
Right. So let's say it's a beautiful day. It's not windy. The contractor has not rented or purchased a tent. How cold can we go?
So per ASTM F2620, you can go to -4 degrees, nothing below -4 degrees or -20 degrees Celsius.
Okay. So basically 0 degrees is our limiter.
Pretty much.
MAB 8, which is the PPI document, says you want it at 32 degrees and preferably above 40. So that's assuming that we're in a tent. So they're saying we want to get it up above 32 degrees. And I'd agree. I mean, I've been out there in 10 degrees, fellas, doing fusions, and it was cold. And it took a long time for that bead to get to size, well outside what McCalc said. But is that okay, Jim, that it takes longer for that bead to get up to size?
It is. There is no maximum heating time. There is a minimum heating time. And so depending upon the size range you're dealing with, below 14-inch, there's just a minimum heating time. Above 14-inch, you have a minimum heating time and a bead size. And so that is okay for that time to be longer. Again, you're not changing the practice. You're hitting that minimum time and going to what the requirement is.
Right.
So it's cold. Be patient. Cold weather is a lot of things. Just think about starting your car, getting your car to warm up, doing all the different things that are part of being out in the cold. It tends to take longer. You're still not changing your practice, but you're being patient about it.
Right. Very cool. All right, Dave, let's say it's raining. What do you tell your guys when it rains and they're supposed to be out there doing fusions? Do you give them a tent? What do you do?
Well, we always talk about protecting the fusion zone. That's the most important area. So yes, it is possible to tent. It is, again, a tent with the backside that's got the backside coming, with facing toward the wind will prevent some of that rain from blowing in. Um, it's just a matter of just using common sense in most cases. Wind probably is the biggest thing we try to mitigate all the time, and
Right.
that could be as simple as parking your pickup truck behind the machine. If I could jump back though, I think one of the most important things when you're talking about tenting this is to look to some of the productivity tools that allow you to use a tent, right? It's difficult to load pipe in a machine when you've got 4 legs sitting outside the machine. When we have larger jobs, that the McElroy Poly Horse is a tremendous tool to be using. It allows us to just create an opening for the pipe to slide off of this. For those of you who aren't familiar with the McElroy Poly Horse, it's a racking system that allows you to load a lot of pipe into the near the machine at one time, and then it can be slid into the machine piece by piece. So that allows us to work in a more controlled tent environment where we're not constantly opening up the tent or having to push back one of the legs or something like that in order to load the pipe. Great tool, great for cold weather. And again, jump back a little farther. Some people ask me, what can I do on the job site to protect the pipe, right? As Chris pointed out, it's really only that first 3 or 4 feet that matter. So we don't say tarp the entire pipe, tarp the ends. Okay, that's where your wind and your snow is going to blow everything in. It's going to blow the moisture in. So we can tarp the ends of the pipe and keep those clean. Then when we get ready to fuse, it's a lot easier to get the machine or to get the pipe in the machine and fuse quickly if we're not having to constantly mitigate every stick of pipe. And we often build little probes that.
All right, Dave, back to you. Why don't you finish that thought?
Yeah, just whatever you can do to think about productivity before you start fusing is really going to help you. So, keep those ends of the pipe protected. When you do go to warm it, you're not going to fuse the middle of the pipe. So it doesn't matter if that's going to be 10 degrees or 40 degrees. It's the end of pipe that's going in the machine that needs to be warm. So get that area that can be warm. And again, just mitigate that wind. You asked about the moisture. It's not uncommon for us to be in a misty rain, and we'll have an umbrella over the heater while it's warming up. And once we get in the fusion zone, we'll put an umbrella over there. When it really starts raining though, there's really nothing you can do. You can't mitigate that moisture. So sometimes it's just time to call it a day and say, listen, this isn't the right time to be fusing pipe. But you can work in a lot of different environments.
Well, it's not unusual. I mean, many construction sites shut down during rain operations.
Mm-hmm.
I mean, that's really normal, particularly when you're dealing with trenches. Right. I mean, that's not uncommon. I mean, it's more of the norm than not. These fittings manufacturers, guys, they like to talk about, oh, you've got to keep that electrofusion coupler in the bag. You've got to keep it, you got to keep it on the truck and you got to keep it heated. But if you do that, that fitting is going to be warm and the pipe's going to be cold. Chris, what do you do when you have a temperature differential and the pipe doesn't fit in the fitting?
Change your environment, do not change your procedure. It rolls back to that even in the electrofusion world. You have to make sure that your electrofusion fitting is outside. The temperature of both pipe and electrofusion are fairly close to the same. You can't leave your coupling sitting in a warm pickup in the middle of the winter because it's going to expand. It's going to fit very loosely. So you have to change that environment, put the electrofusion coupling out there where you're going to keep it wrapped in the bag. It'll still cool off and then it'll fit on the pipe properly. And vice versa the other way too. If your pipe's too hot and your electrofusion coupling's too cold, you've got to get them calibrated or set to basically the same ambient temperature.
So, Dave, when you're on a job site, are you telling your guys to put a tarp over the pipe or just the pipe ends? I mean, what is your expectation on a job site?
It really depends on the job. If it's a large diameter job, sometimes that can be real beneficial too, because then you can get a lot of snow and ice in the pipe on a large diameter job. You have a lot more cleaning to do, right? It's easier to clean off a piece of 4-inch pipe than it is a piece of 24-inch pipe. So if you can mitigate some of that that snow and ice building up on the pipe, on especially for larger diameters, it can be a big help. When we start talking productivity, as Chris pointed out, you can get anything dry if you have enough time and enough towels. But it's that time that really zaps your productivity. And if you don't think about that, then you're going to be 2 steps forward, 1 step back all day long, and you'll have half the productivity when it's cold out.
Yeah, I just add one thing there, that especially the larger diameter, it really helps to get all that snow and ice off of it, especially if you're in a fuse and pull situation where the machine is stationary and I'm going to pull that piece of pipe through the machine. So I've got my first section where I'm fusing nice and clean, but now I'm going to pull the rest of the pipe all the way through the machine. If it's covered in snow and ice, I'm now just knocking potentially snow and ice and moisture onto various parts of the machine that I'm going to have to clean up before I start my next fusion. So in that case, a lot of times it helps to have that whole pipe clean. If I'm pulling that pipe out of the machine and moving it down, less of a concern, or if I'm moving the machine to the next joint. But when I'm fusing and pulling, a lot of times it really does help to clean that whole pipe section off, to just minimize some of the time spent cleaning off the machine.
So how do you do that? Do you water jet it? Chris, have you ever done that?
I have not. I mean, the only way that I clean the pipe ultimately is just take a towel and clean the pipe going down, whether it's a 40 or 50-foot stick. I spend more time, like Jim said, cleaning out the machine. By the time you get to the rollers, it knocks some of that off there where it doesn't all go in the machine. But ultimately, you can spend a lot of time cleaning that pipe. And if you just keep cleaning on it or let some of that stuff fall in there and clean your machine out, it's kind of centralized at that point.
Right.
If you're
Dave.
on a power course, that rolling of the pipe as it goes down into from the rack end helps knock some of that off as well. And just a big sweep brush sometimes.
All right. So Dave, I hear you have a cold weather story you want to share.
Well, we've done all sorts of them, as you can imagine. We've got, if they're in North Dakota, sometimes the wind can be worse than the snow itself. I mean, it blows and it blows and it blows. So we've had projects up there, and you just have to make sure that you're mitigating that wind at all times. I'm trying to think of a really good specific story here, Peter. If I come up with one, I'll jump back in.
All right.
Yeah, the guys see all sorts of stuff. One thing to keep in mind when it's cold out like this, and we had someone, last week, that it gets a little more dangerous on the job site. So make sure that everything that you've got your points of contact at all time, that you're not relying on one hand as you jump across the pipe, and that kind of things. Everything's slippery. It's very easy to get hurt when it's cold out. So just tell the guys, slow down, take your time, be safe.
Okay. So I hear a lot about the phrase preheating, and it makes me a little uncomfortable because it means different things to different people. It could mean preheating the heater plate. It could mean preheating the machine. It could be, getting the hydraulic fluid up to temperature so the McElroy machine works correctly. Jim, what is the best practice specifically to preheat the pipe ends? Is it a heater blanket? Is it just get it into a tent? I mean, if you had your druthers and you said, this is the way to preheat the pipe end so that fusion goes better, what would it be?
Well, it's kind of unique to each job site. That the ideal situation is if I had a tent on site that had a heater in it that was roughly the same temperature as my fusion tent, that I would have that pipe stored in that tent in that way. So that's a really great way to do it if you have the time, the space, the other things. Otherwise, a non-flamed heater pointed at the end of the pipe to help to help give you some heat on that. Remember, the polyethylene is a fantastic insulator, so it takes a little bit of time to heat that up. That's why we make Yeti coolers and Arctic coolers and everything else out of polyethylene, because they're great insulators. So they are slow to heat up. They're slow to cool down. So doing that, there are heating blankets out there, industrial heating blankets. You've got to be careful with the industrial heating blankets to make sure that you use an industrial heating blanket. You don't want a blanket off your bed, but you want an industrial heating blanket that doesn't go above 100 and say 80 degrees Fahrenheit. You want something in that 150 to 175 degree range to wrap the ends of the pipe.
All right. So let's say you don't have one of those, but you have one of those heaters that blows air. What are those torpedo looking ones called?
Salamanders.
Yeah, the salamanders. And Jim, let's say you only have one and it's blowing heat on one side of the pipe. So one of them gets up to, 110 degrees and the other side's at 80. You're going to end up with a weird looking bead, aren't you?
You could, if they're not going to have just a massive difference there, but you could have some variation there, rotating the pipe, spinning the pipe. Shooting the heater down from the end gives you some heat that will shoot down the pipe rather than and heat the entire pipe or a stack or a bundle. Gives you that ability to give you a little bit more uniformity there. What we're looking for is getting that temperature, above 32 degrees, say, whatever that may be for your job site. And that the two pipe ends don't have massively different pieces, so that I don't have one pipe end that is 5 degrees and one that's 80 degrees. I want to have some consistency in the two pipe ends that I'm fusing. They don't have to be exactly the same, but they need to be close to each other. You can then also finish that out by by putting the pipe into the machine and using the heater itself to heat up the ends. No, don't bring the pipe into contact with the heater, but bring it within, say, a half an inch to a half inch, and letting that convective force from the heater heat the ends of the pipe, and so you get a little bit more stability.
So this isn't covered in MOB and the MAB from PPI. So
Right.
Specifically, you're saying the best practice is if your pipe is sitting there at 10 degrees Fahrenheit, your preference as the guy that makes the machines would be to have, and you had a tent, would be to have the guys get that pipe end up above 32 degrees before the fusion process starts.
Yeah, and I just picked 32 degrees. It doesn't really have to be that. Chris, Dave, I don't know if you guys have had any specific experience. That's not a hard recommendation, but you don't want that temperature down below 0, because we want that material to be able to flow and build up that bead. Remember, that bead is going to take a little bit longer to form. And if you're just bringing that cold pipe against the heater, then you're sucking heat out of the heater. It takes longer for the heater to heat up and get to form the bead. So the warmer the pipe, the more closely it will be to the standard time that you're used to seeing on a sunny day.
Got it. But there is no, we're not going to damage the resin in the pipe if we start it at 0 and we stick it on a 400 degree plate.
Correct.
It's just going to take longer, and therefore you're not going to be as worried that you're messing up because it's taking so much longer.
That's correct.
Got it.
Correct.
Chris, what's the weirdest thing that's happened to you on a job site in inclement weather?
There's been a lot of crazy things come about. To reach back to Dave's comment earlier about the wind, you get out there and you start making these fusions and you think, man, I've got all the time in the world to open and close. And you start seeing white stripes in the middle of your fusion beads. and you can't figure it out. And you do a little research and you figure out that your open and close time is too long, and you got to go back and cut them all out because they're actually cold fusions. That's probably the worst thing that's ever happened to me on a location.
What's a white stripe?
So when you bring the molten material together, if you leave it open too long, it's like taking a milk jug and cutting a strip and bending it. It turns white in the middle. It's doing the same thing to the polyethylene because it's super cooled and it's stretching that material instead of actually bonding that material to each other.
Wow. Do you have any pictures of that?
I do. I'll send some to you after the podcast here.
That's crazy. I didn't know that was a thing. I thought you were talking about window painting.
No.
No, that's interesting. Dan put together a bunch of questions that we got from the webinar. One of them that's really interesting to me is, what should an inspector be looking for, Dave, in cold weather operations versus normal operations? We're really putting a push in, certainly in municipal world, to get owners and consulting civils qualified to be inspectors. Dave, what should they be looking for?
Well, they should be looking to make sure that heating times are longer than minimums. I mean, it's not unusual these days with some of our higher performing residents, even in.
All right, Dan, we got some more work for you here.
Got it. Start back whenever you want.
Yeah. All right, Dave, you're back. Dave,
I dropped out there.
Sorry, Dave, what should we be looking for? What should those inspectors be looking for in cold weather fusion operations?
Well, as we've mentioned a few times, time is what they should be looking for. They should be making sure that the data logger reports, and I encourage everyone to use a data logger to record the times and pressures that are used in their fusion. They should be looking for those to show heating times that are significantly longer than what you would consider a minimum heating time, which would be 4.5 inches per inch of sidewall thickness. Okay. Be looking for that. We also, we've got a heater range of 400 to 450 degrees, and we typically shoot for 425. But if we're fusing in colder temperatures, we may want to move that up to 440 is what we're looking for on our heater temperature. It's still an acceptable temperature, just a little bit higher. That's going to, the heaters cycle on and off, right, as we have them set. So if we had it set at 425, it might get down to 400 quickly and then have to cycle back up. So we can set that heater a little bit higher. Look, and so that should all be reflected in the data logger report as well. But just so important to use that, the process that he mentioned about the preheating the pipes, that is actually in Appendix A1 of F2620, bringing the pipe ends within 1/4 to 1/2 inch of pipe and letting them soak for 30 seconds to 2 minutes. That we find is the best way to do it. Again, we just have time. We can add more time on the heat, and as Chris said, reduce time on that open close. So if we see open close times on a data logger report that are closer to the maximum, we know that we might have some issues. We do encourage engineers on their specs to put in recording the ambient temperature. Not everyone has that. It's available now on the data logger. So we do encourage that we put that in the specs, so we've got complete information on that data logger report, so we can read that and interpret it in relation to the environmental conditions that we're dealing with.
So you just brought up 2620 has an appendix and it covers cold weather fusion operations. Is that correct?
Yes, it's Appendix A1.
Okay. So that's another resource that we can list in our notes, Dan, that people can go to learn more.
And
Real quick, Peter, let me jump in.
procedures.
I want to thank Jim. He did teach me a good lesson. Jim, I don't know if you remember where this conversation took place, maybe Showcase, but you said, be careful specifying specific standards rather than list a standard, and advise them to follow the most up-to-date. That was a good lesson. So for specifying engineers, that's definitely a takeaway that I have found really valuable, and not doing the same work twice. That's been very helpful.
So specifically, let's talk about ASTM F2620. When I refer to ASTM F2620, I'm always talking about the current version of ASTM F2620. If somebody writes in their specification ASTM F2620-13, then that's the one that Chris talked about earlier, which says wash with water after wiping down with alcohol. Well, if you are very specific about the addition of the standard, then you don't have any leeway. If you're always referring to the standard itself without the specific addition, use the current version. It's the most up to date. It is the most modern. It incorporates modern materials, modern procedures, anything that's an issue. So best practice is always to try and do that. The other piece I wanted to thank Dave for here was he noted the heater temperatures. So we talk about polyethylene being an incredibly forgiving material. You can do a lot of things with polyethylene and never mess it up. The standard allows 400 to 450 degrees on the heater temperature. Take advantage of that range. Cold weather, you can go up to 450. Do not go outside that range. We know what the standard does within the ranges of a process. 400 to 450 makes a good joint. You go to 490 or to 520, we don't know what the standard does. So 400 to 450 is the allowable range. Use the allowable range. So there's an opportunity to do that. Same with the pressures, 60 to 90 psi, very wide range. You can fuse just as well at 60 psi as you do at 90 psi. And daily conditions, we kind of hit that. We always train to that middle of the road, 425 and 75 psi. But in cold weather situations, go ahead and go on up to that higher end of that heater.
So, Jim, there are a couple things that interest me. One is when we're doing an in-ditch butt fusion in the cold, that hydraulic pressure takes a while for it to make it into the trench because the hoses are longer, because those guys use those hose extension kits. Is there a best practice there for that we need to pay attention to? Or does it just take longer and you just got to pay attention? I'm sure the data logger shows it, it shows up weird on the data logger with a hose extension kit. Help me understand that.
So you're essentially putting in, think of it as a spring into the hydraulic system. So you have expansion and contraction of the hoses and those longer hoses from the traditional system. If you're using a data logger, there's actually a check mark to note that you're using extension hoses, and you'll see some variation. You'll see some spikes because where we're measuring the pressure is at the valve rather than at the cylinder head. So you're going to see some transactions in there. If I've checked the fact that I'm using extension hoses, then I'll see any spikes in the data logger graph and know that they are because of the of the extension hoses. Makes perfectly good joints, makes everything else. You just can see because of the ability of that transducer to see such a small fluctuation. You can see fluctuations in the system due to those hoses versus a traditional analog gauge in silicone. You won't see that variation in the needle, but you will see it with a data log.
So if I rent or buy a hose extension kit, do those hoses have hydraulic fluid in them?
They are pre-charged, yes. Okay. Yep. So you're not drawing down the system. You're not changing the system. Those are always pre-charged so that you don't get any air in the system. You don't lower your fluid. Let's say you're at the low end of your fluid. You would never want to have an empty hose because you're now lowering your overall system. Right. So those are pre-charged.
And one final question on McElroy. What if I'm a tech or I'm an inspector? What do I want to make sure that my tech's paying attention to in the cold as far as the machine goes? Does it just take longer to warm up and everything's cool? Is there anything else I need to look for?
You want to make sure if you're in an extreme environment. So let's say the outside temperature is -30. You're taking care of that. So if you've got heavy equipment, you know how to take care of that. If you have a diesel system, you're knowing what kind of additives to have in your diesel or block heaters to have in your diesel systems. Hydraulic oils have a temperature range. So look at your hydraulic oils and make sure that they are compatible with the range of products that you're doing. I talked to a guy not too long ago who is above the Arctic Circle in Alaska, and their daytime temperatures were minus 30. So just storing the equipment, that hydraulic oil's got to be changed out to a hydraulic oil that works in those lower temperatures. They're obviously working in an enclosure, but the equipment is exposed to just really massive systems. You want to warm up the equipment. One of the things, I think Chris and I talked about this at Showcase, one of the ways to warm up the system is to start your machine and run the facer before you do anything else. Just turn the facer on. There's small orifices in those systems that you're forcing the hydraulic oil fluid through. It makes it hotter, helps to heat the system up a little bit faster.
Nice.
So you want that hydraulic oil flowing so that it is heating up and warming up. So it's a great way to do it. If you're in a machine shop, you want to get your machines started and running and hydraulic oil systems going before you start your day. Anything you're doing, whether it's a bulldozer or a McElroy piece of equipment, you want to get everything running and warmed up. Before you make a long drive at minus 20 degrees, it's good to start your car and get the heater going.
Yeah, that's good stuff. Jim Johnston, great job today. Chris Waite, final remarks. Anything else you'd like to add to the conversation?
Just to touch base on what Jim's saying there on the warming up of your equipment. I've ran into multiple situations where these guys are out in the field. They're fusing North Dakota last week as a prime example. They were doing some final tie-in fusions on the line up there, and they were pushing like 24 to 26 below ambient with over 40 to 50 below wind chill. And they call me, the machine won't clamp. It's because they didn't warm the machine up properly. So you have to be sure that you're warming these machines up properly. You have to be sure that you're setting your fusion pressures. But the one thing that I would tell you in the wintertime and cold weather procedures is that 60 to 90 PSI interfacial pressure range. If you jump that up to closer to the 90 in the wintertime, that jaw is going to move faster. You're less apt to get a cold fusion with the white stripe in the middle of it because the jaw is going to move faster to get that pipe back together.
Fantastic advice. I think that's what our audience wants to hear, stuff like that. That is awesome, Chris. Great job today. Thank you. Dave Mosier.
Chris brings up a good point there with the force capability versus speed, that you have a trade-off, right? So if you've got a medium diameter cylinder, it's going to move faster than a large diameter cylinder. So for example, on our 412s machines, our McElroy 412 track stars, we typically have been going with the medium pressure. So we don't have as much available pressure in the machine, but it actually moves faster, allows us to get our open and close times quicker, which is important.
So that means you're not buying the high force, you're buying the medium force?
We're buying some, but we do find applications, especially for smaller diameter, and for cold weather, where it's better to have a medium force because we have more speed.
Okay. So what he's talking about, the McElroy offers different forces. So you can buy a 412 track machine, high force, or you can purchase one that's a medium force. Do you have low force ones, Jim?
We do have low force machines. And those are primarily for the international markets. There are a few in the U.S., but they're very fast. But those are primarily for the ISO and DVS standards used internationally.
All right, Dave, back to you.
Yeah, and then one thing we try to remain aware of in the field is the jaw inserts, right? They're serrated so that they can grip the pipe. Well, as the pipe gets colder, it doesn't grip as well. So we try to make sure that we don't have any debris in those serrations, that they're clean and sharp so they can grip onto the pipe. I have gone out on job sites that did not have my guys on them, and I've seen those caked with mud, or there's stuff in there. You're wondering, how is that ever going to grip? So just maintain your machine, keep it clean, keep those jaw inserts clean. As Chris said, adjust your interfacial. If you're pulling two two lines together for a tie-in, you may need to reduce your interfacial pressure in order to have the force capability available in the machine. So there's no substitute for an experienced operator, which of course Chris is. He's seen a lot of stuff, and I've spent my share of time in the ditch, and you just look and learn. And every day has got to be you got to be open-minded when you're out there, because you're going to find a new challenge.
So those inserts are kind of like a 9-iron. You got to get your tee and clean out the teeth so you can grip, right?
That's it.
Yeah, fantastic. Great job,
Peter.
Dave.
If you don't mind, I think that's a great point. One of the things that we didn't really talk about today was expansion capability of expansion contraction of HDPE. So cold pipe is going to contract, and so if you've got pipe on size in very, very cold pipe, it is going to be smaller, and so you may be clamping a little bit harder than you would, or adjusting your clamp depth. So it's just really critical that you check your slippage, you check your clamping on cold pipe for that very fact, because it may not. If I was fusing at 60 degrees yesterday and 20 degrees today, where I'm used to clamping that pipe than it is on the 60-degree pipe.
So at what point in the process do fusion techs check for slippage?
So typically, and I'll let Chris go ahead.
I typically will when I load my pipe in there, before I ever even face it, I'll put a mark on the outside of the jaw. So when I bring it up against the facer, yes, we're only in facing pressure at that point, but you're going to know a lot about it then. And then once you've faced and you check your high-low alignment is really when you're going to know about it, because I'm going to do that initially in facing pressure, but I'm going to change it to fusion pressure just to make sure that I don't have any slippage. And by drawing a line right up against the insert on the outside of the jaw, you can tell if you have slippage at that point. If it slips any at all, you need to stop what you're doing and readjust.
Yeah.
We typically teach to do that right after you set your drag. So you'll set your drag pressure, then you'll drop it down into fusion pressure, make sure your fusion pressure is correct. And at that point, give it a couple little bumps right there. And if it doesn't slip, then just leave it together and you're ready to, go tend to your heater.
Right. Makes sense. Dan Landy, any final words?
We covered a lot today in a lot of different situations between here, now, the webinar, other presentations, but I think Dave alluded to a lot of things are going to come up still outside of normal operating conditions. I think it's important to know what normal operating conditions are. And then if you are getting outside of those windows, make sure you're contacting your local fusion experts, whoever that may be, wherever you are in the country. So a lot of people here to help, and just knowing that you can utilize those is half the battle.
All right. I'm going to ask my speakers to give their email address for contact information. Chris Waite, please start.
Mine is c.wait, WEIGHT, at Secor, SECOR, online.com.
Great job today. Jim Johnston.
Mine is J Johnston, JOHNSTON, at McElroy.com, MCELROY.
Awesome. Dave Mosier.
Mine is David Mosier, MOSIER, at Core and Maine, all spelled out, COREAND.
Awesome. And then Dan Landy is DLandy, DLANDY, at pepipe.org. And I'm PDyke, PDYKE, at pepipe.org. Thank you so much for listening to this edition of the Poly Podcast. What a great topic. I learned a ton today. You guys have been great speakers. Look forward to it. Dan's going to publish this on YouTube as well. So until next time, thank you to WL Plastics for hosting this and sponsoring it. And thank you to my panelists for a great job. See you at the next Poly Podcast.